Previously, we created a data frame called df underscore final that contains all the necessary information about each country. That is the inflation rate, growth rate, whether the country is included in scope or not, and which region it belongs to. Now, with this information, I want to do some fundamental analysis. I want to know which country fares how with respect to inflation rate, growth rate, do some categorical analysis, and understand the overall situation amongst the country's performances. This is an example of fundamental analysis. Let's see how to do it in R. Let's begin by importing the df underscore final.csv we created in the previous video. So we have the country, GDP growth, date I am not so much interested, inflation rate, which region the country belongs to, and whether it is included in the scope or not. This information we have. Let's start by understanding the inflation rate. So the mean inflation rate experienced by all the countries in the data set is 5.64. Now I want to understand where the countries stand. So let's sort it by inflation rate. So these are the countries that face the least inflation rate. The lowest one is Libya. And you can observe that these are negative values as well, which may not really be favorable for an economic climate. Now let's examine the countries with highest inflation rate. So I am sorting it in descending order. So we have Zimbabwe, which has an inflation rate of 288%, and these are the countries that are experiencing too much inflation. These are also not so favorable. Now let's look at the quarterly performances. So there is another file called qtr underscore scores.csv in the input folder. I'm importing it. These are financial performance score of the company over the 4 quarters from years 2014 to 2018. This is on a scale of 100. Let's compute the column mean and the row mean of this. A column mean of the score data frame would essentially give you the annual average of the company across that particular year, whereas a row mean would give a quarterly average across the years. Let's compute that. So this tells us that the company's performance improved from 2014 to 2016, where it peaked to a value of 93 and then it started seeing a decline. Now it is at its lowest that it has seen in the last 5 years. Let's understand the quarterly performances as well. There is not so much variation. While quarter 4 seems to be the best performing and quarter 1 seems to be the second best, quarter 2 and 3 is approximately at 86.3% on an average between these two numbers. Just for illustration purposes, now that you have seen row means and column means, let's see row sums as well as column sums. So score looks like this. Doing a row sums of this will give you the sum of every row present in this particular data frame. Now these are the row sums. Likewise, column sums is this, and cumulative sum will cumulatively do the sum within each column. So it starts by 82, 82 plus 85, 85 plus 8. Then in the third row, the sum of these first three numbers and so on. This is the cumulative sum column wise. Now let's do some frequency tables. Now we have GDP growth. Now I want to categorize this GDP growth into high, medium and low. And these are the rules to create high, medium and low. I'm going to use the if else function where if annual GDP growth is greater than 5, I'm marking it as high. And if it is between 5 and 2, I'm marking it as medium, else it is low. I'm storing it in GDP underscore cat variable. Let's look at the contents of df. The new column is now created. Now I want to understand the distribution of the countries by GDP growth. To do that, use the table function, and it tells that 39 countries are present in the high category, which is more than 5% GDP growth, while 61% is in low category. Let me write it off also. Now I have updated the dffinal.csv file to include the categorical column, which is GDP underscore cat. So this is the overall split of GDP growth, but I want to understand how the GDP growth is between the operating regions. How to do that? Now you can do the same using table function, but you need to pass two arguments, that is both the GDP underscore cat as well as the operating region. The way table functions is the argument that you pass as the first one in table function will go into the rows, whereas the second argument goes into the columns. Now, when you try to view the table, it comes out in a different format because the output of the table function is not really a data frame. If you check the class of TB, it is of class table. So sometimes you want to convert this table to a tabular format, such as a data frame or a matrix. Let's try to do that. If I convert it using as.data.frame function, it doesn't really work. Now this is converted to a data frame, but when you try to view this object, it is still showing up in this format, which is harder for us to digest. Now converting it into a matrix using as.matrix does not work as well, because even after as.matrix, the class is still table, and if you try to view it also, it comes in a different format. The correct way to convert a table object to a data frame is using this particular function called as.data.frame.matrix. Now this looks nice. Now this is really a data frame. If you try to view it, it comes out in the nice desired format. You might think, why do I even need to convert it to a data frame? Can't I keep it just as a table object itself? The reason is, if you want to write this particular file, particular object to a file, or you want to make further manipulations on top of it, you need to convert it to a data frame. If you want to access a particular row or column in that cell, making it as a data frame is more convenient for further operations on it. Alright, now let's see something a bit more involved. Now this is a frequency table, also called as a contingency table. Here you have the number of countries or the number of records in your data set that fall under this particular category. High GDP growth, that falls under Africa. Now suppose I want to see what is the average inflation rate of countries that are in Africa and have a high GDP growth. How do I do that? So instead of having the number of records that fall under this specification, I want to compute the mean of the inflation for countries with both of these satisfied. In fact, for all the values in this particular table. This can be done using something like a pivot table. If you are familiar with spreadsheet software such as Microsoft Excel or Google Spreadsheets, you have an option to create pivot tables out of two or more columns in your dataset. Now let's see how to create such pivot table based on the GDP growth rate category and the operating region. So let's capture average inflation rate by GDP cat versus operating region. This facility is present in a package called Reshape2. Inside Reshape2, there's a function called dcast. I'm going to use dcast to create the pivot table. So inside dcast, you need to pass firstly the formula that you want to create for the pivot table. Now how to write your formula depends on what you want to have on your rows and the columns. So in my rows, I want the GDP underscore cat, and in columns I want operating region. So that is the very first argument. Second argument, I need to pass the data, which is nothing but df itself. I also need to tell dcast based on what column the values inside the pivot table should be filled up. So that you need to pass it into a variable called value.var, and in this case the variable is last inflation. Just to see if I have spelled it right, let's check the top n rows and copy directly from there. Alright, and based on what function this particular column should be aggregated, should be specified in this particular argument called fun.aggregate, and I'm going to aggregate based on the mean. I want to compute the mean of last inflation column for every possible combination of GDP CAT and operating region. On running this, you get a nice pivot table where you have GDP CAT on the first column. For every operating region, you have the mean last inflation column. You have in certain places NAN stands for not a number. This typically happens when there is no record for this particular combination. So it means that there is no record for America where the GDP growth rate is high category. So as a practice exercise, try out all the functions, especially the table function and the dcast function in your RStudio, because these functions are often used in data analysis and you need to know it like the back of your hand.